Okay, so I really want to highlight what I'm going to call sinusoidal correspondence. Graphing sine functions is really a two-step numerical process. And the first step is a linear component where um, the x values get converted to locations on the unit circle. And then, depending upon what you're looking at, you might find it easier to do sine or cosine, depending upon the location on the unit circle. Most textbooks start with converting the x value to 0. And so if you're looking at the cosine of 0, which is 1, then you might, start at a max and model with a cosine function. The sine of 0 is 0, so if you were in the middle, well, that would be a sine function, but it would be negative because heights are going down. I'm going to do it from a kind of an orthodox situation, one that I don't see in the textbooks. But first, we'll do a standard one from textbook perspective. All right, so we've got typical sinusoidal pattern. Let's get some numbers that have some familiarity. 2020. All right, so this year we got 100 sheep. And over here, let's go to 2029. Let's say we got 50 sheep. Well, sinusoids, the pattern is measured from the middle line, the midline, which is 75. So this function, we'll do a couple of these for practice after I explain. Hopefully, start the learning process. So you start from the midline. So my calculation starts from 75. I'm going to use a cosine function, and from 75, I'm going up 25. The cosine of whatever I write here, this part of the calculation is going to get numbers between 0 and 1. So the biggest it can be is 1. The highest I can get is 100. The smallest it can be is -1. The whole calculation, right? This part of the calculation is actually the linear component that I want to stress in this video, okay? So I'm not going to graph from the textbook setup because textbook forces the period 2 pi. I'm going to graph from what I see. So I see 1 revolution to here. 1 revolution is 2 pi units, right? So this is 1 pi, 180 degrees, takes me from max over here to min. This is 1, this is -1 for cosine. So this is pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi corresponds to a change of 9 years. So in 9 years, I want to go around twice and a half. And when I go around once, 2.5, I'm over here at a minimum, which is what I get there, providing I begin my analysis from the year 2020. Okay, so we'll just put 2020 in. 2020, cosine is 0, 1 times 25, 25 plus 75, 100. 2029 minus 2020 is 9, divided by 9. Years cancel. 5 pi is a place on the unit circle, which is here. Cosine -1, -1 times 25 minus 25 plus 75, 50. We'll practice that at the end of this video a little bit, okay? If I wanted to start here at positive cosine, I could build negative sine function here because I'm in the middle going down. If I had a location here, I would be from a negative cosine perspective because I'm at a minimum. If I started there, positive sine, positive cosine, negative sine, negative cosine, positive sine, middle and going up, positive sine, maximum width, right? Maximum width here, so cosine, positive cosine, negative sine function, negative cosine. This is what traditionally we do. But what I want to highlight is the linear aspect here of converting a radian measurement to a place on the number line. What do I mean by that? These are sometimes referred to as unwrapping functions. All right, so you got your x-axis is actually the circumference of the circle. So I am taking numbers on the x-axis and converting them to places on the circle. So that's 0, that's pi over 2 of the distance. Okay, I have to make a smaller circle. If I'm going to do a 1-to-1 correspondence, there's a smaller circle, okay? So from here to here, that distance goes from 0 to, that distance looks to be about there, pi over 2. And then we go here, that's pi, right? So on and so forth. That's your x-axis, okay? That becomes your x-axis. when dealing with kind of a one-to-one correspondence. All right, so I'm not sure I said that quite the way I wanted to, but that's why repetition is our friend. We have a chance to the rest of the semester to talk about this. All right, so what if I had the same function, but I wanted to graph it from the sine perspective? I could do this an infinite number of ways. So here, let's get back to our sinusoid. Let's get back to 2020 and what was 100. And let's get 1, 2, 3, 4, 5, 20, 29. Gets you 50, and our midline is 75, right? So I'm going to do it as a sine function now. So in the sine function, where's a max? Because sine measures opposite side to hypotenuse. I like to just say height in the unit circle. Where's the height of max? Ooh, that's pi over 2. So I want 2020 to correspond to pi over 2 on the sine function. And I want 2029. Well, let's see how far we go. We go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. I've got 5 pi units of change. That must mean that this is 5 pi plus pi over 2. Yeah, let's come back to that in a minute. Yep, so 9 pi. Yep, 5 pi plus pi over 2. When I put 2029 in. Okay, so let's do the function. Let's do the numbers. NPR, marketplace. Let's do the numbers. So how do you write the equation of line? We've gotten good at that. We started that day one. Yeah. So x minus 2020. I know I've changed by 9. My x's have changed by 9. And my y's have changed by 5 pi. And when I put 2020 in, I want pi over 2. I usually write that immediately. Okay, so there's my correspondence. All right, so let's actually see how this works as a sine function, because it sure seems like 75 plus 25. Oh, I didn't make enough room there. Let's put the sine in first. The sine of this correspondence, getting all those ones and negative ones, amplified by 25 plus 75, should be my function. So let's put 2020 in. 2020 minus 2020 times 5 pi over 9 is 0 plus pi over 2. Well, what's the sine of pi over 2? Sine of pi over 2, we've done that enough. There you are, good drawing. That's a 1 times 25, 25 plus that. Geez, it works for that. How about we plug in 2029? Oh, that gets me 9. That gets me 5 pi plus pi over 2. Well, let's do a little drawing. 5 pi, odd pi. That's over here. That's 5 pi. Well, 1 pi, 2 pi, 3 pi, 4 pi, 5. Yep, it's right there. Plus pi over 2 puts me here. And what's the sine value right there? Oh, I got to get the video down a little bit. Sorry, folks. So again, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi is right here. And another 90 degrees puts me there. And what is the sine, the value of the sine function? Right there. Minus 1. Minus 1 times 25, minus 25 plus 75. Oh, yes, 50. Let's get that parentheses in there. Okay, so what am I trying to highlight? That this is a linear relationship where we're trying to take the x values and match them up to where we are on the circle with respect to sine or cosine functions. Okay, now, not going to do that. We're going to stick with the traditional, if we're here, it's a positive cosine here, negative sine in the middle, negative sine and going down. The bottom, we're going to use a negative cosine function to model. Right here in the middle going up, we're going to use the sine function to model. Right here, we're going to use the positive cosine function to model. Right here, we're going to use the minus sine function to model. Right here, we're going to use the minus cosine function to model. Right here in the middle going up, we're going to use the positive sine function, whereas over here in the middle going down, negative sine function. I hope you get the idea. With a repetition, we can get quick at this. All right, so let's do some quick repetition. All right, I'm going to stick with positive cosine and negative cosine. All right, just to get the idea. And the typical problems you look at coming from the textbooks are Mark Twain and the steamboats, Ferris wheel problems, sinusoidal, periodic functions, fox population, rabbit population, more foxes, less rabbits, more so on and so forth. So let's do this one. Let's just go from here. Let's start with in 1900, there were 50 foxes. out backyard, you know, in 1907, we noticed that there were 70 foxes, all right? And it's a sinusoidal pattern. You can pause the video, try to see if you can get this. I don't have to pause. So y equals, I know my midline is 60. I know this is a negative cosine because I'm going down 10 to get to 50. And I want 1900, so time, can I go t? I like t for time. I'm going to start writing these fox population as a function of time. I like that better. T minus 1900, that gets me my 0 and the sine of 0. The sine of 0 is the height on the unit circle. Oh, there's no height here. This whole thing disappears and I get 60. Oh, wait a minute, I'm doing cosine. My fault. Cosine. I got, when I went back to the other video 10 minutes ago. All right. Cosine. Oh, the cosine is 1. That's 0. Oh, but I'm multiplying it by minus 10, so that takes me down 10 from 60 to 50. Ah, that seems right. Now I got to do my counting. 1 pi, 2 pi, 3 pi. And that corresponds to what? Boop, 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 boop. 7 years of occurrence. That's that function. Let's do another one. All right, let's do this one. Let's do this one. Let's say that in 2025, we had 1,000 ducks on the pond. Now, I don't want to use animals anymore. I don't like the population going down. I like ducks. We got 1,000, my hand, 1,000 feet from the center. All right, let's go over to here. So something is 1,000 feet up from something, right? Oh, well, you're supposed to figure that out. All right, so let's go to 2031. And let's go down to 800. Okay, you hit the space bar. I don't have to. So this is a positive cosine. So we're starting from the center line, 800 to 1,000. Must be 900. To get from 900 boop, 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 to up to 1,000, we got to go up 100. It's a cosine function. We want to make a 0 out of what? 2025. So t minus 2025. Oh, I forgot to write height as a function of time, or distance from the center line. Distance from the center line as a function of time. So what's elapsed? 6 years has elapsed, and we want 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi. So 5 pi and 6, we're going to find some shortcuts for finding the period. The period of the function is from here to here. A lot of standardized tests will ask you to find the period of the function. So what's the period of the function? It's a proportion. 2 pi over what? And there's going to be shortcuts to how we do this, and I'll explain those later. Maybe I'll throw them in this. The shortcut is to take the multiplier times the variable. The multiplier times the variable is divided into 2 pi. Okay? So this is the same thing as 2 pi divided by 5 pi over 6, which is 6 over 5 pi as a multiplication, right? The pi's cancel. I get 12 over 5. So every 5 years, I go, that didn't make sense to me. Every 5 years, I go 12 units on the x-axis. What did I just do that I didn't like? 5 pi over 6 equals 2 pi over what? Let's do this one. See the correspondence. So 5 pi x equals 12 pi. X is equal to 12 pi over 4 over 5. Oh, so I said it awkwardly. So it's 5 and a 12, 2.4, right? So I'm a little tired here. So every 2.4 years, you've got one revolution. So if this is 2.4, that's 2.4, and we went a half, so that's 1.2. That should add up to 6. 4.8 plus 1.2 does add up to 6. Excuse the onset of dementia with the old guy. All right, so that's your shortcut, 2 pi over m. Remember, this is really a linear function. I could convert it to mx plus b. I could convert that to mx plus b. And if you find m and divide it into 2 pi, you got the period of a function. Now let's do one more. One more cosine, and then we'll have one sine function. And that's enough, I think, help for getting you started on graphing gets the conversation started, and we'll continue to do it the rest of the semester. All right, so one more cosine function. There we go. There we go. So the Ferris wheel, was 6 feet off the ground when it hits a minimum, and that happened 47 seconds after the guy hit the switch. You were 6 feet off the ground, and you went around. You got a nice friend in the Ferris wheel, and 1, 2, 3, 4. So you're here, and that took about 30 seconds to get there. So at 77, you're back at the height, and the height of the Ferris wheel is 56 units, 56 feet. You got a good view of the fairgrounds. All right, so we're converting time again to feet. So height of the Ferris wheel, sitting on the Ferris wheel. We're here. Oh, that's a negative cosine, but we got to find the midline. So what's halfway between 6 and 56? Probably 36. Nah, it didn't do that right. So it's added up. 62 divided by 2 is 31. So 31. So that kind of tells us the radius of the Ferris wheel, the diameter as well. I just want to check that real quick. Up 25, up 25. Yeah, that's right. And so we're going up and down 25 units from the midline. And it's over here, we're going to go to a minimum. So we're going to use a negative cosine. All right, so minus 25 in this case, cosine. And let's do it from left to right this time. So we got 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Then that took 47 to 77, 30 units of time, right? 47, yep, 30 units of time. I don't want to make a 0 out of 47. Can you see everything? Yeah. So t minus 47. There, go have a nice ride. Okay, so what did it take to make 1 revolution? From here to here, what's 1 revolution? Again, the shortcut, and this is really pi over 6. You're going to divide that into 2 pi, and you're going to get 6, and the pi's count 12 seconds. All right, it's going to take 12 seconds. So 12, 24, and 6, 30, right? Because that's a half. So it's 6 seconds. That's 12. That's 12. There's your 30. Okay. And, you also, before taking the shortcut, I probably would have taught this from the standpoint of cosine of 0 is what you want, and cosine of 2 pi, right? So I'm just shortcutting, saying pi over 6. When does this thing equal 0? Well, you can get that easy, right? That's the starting point. You're always looking for that. And then when does pi over 6 times t minus 47 equal 2 pi? Because that's the end of the first revolution, right? Go Che Guevara, the end of the revolution. And so let's just solve that real quick. And then when we do, we're going to see that this is equal to, this value here is going to be equal to 47 plus 12. Okay, when we solve that. Oh, let's get over here. Oh, God, it's terrible. I'm making a terrible video here. I'm not even including you in watching this. So back again, we want to make this thing here, this argument equal to 0, which is here, and then 2 pi, which is the same place. That's 1 revolution. Okay, it's easy to see what makes it 0, 47. I'm now going to solve it for 2 pi. And what I'm suggesting is we're going to get 47 plus 12, which means that your first minimum, your second minimum, here's your first, is equal to what, 59? That's your second minimum. All right, so step 1, multiply by 6. There's 12 pi. Divide by pi, there's your 12. Add 47, there's your 47 plus 12. Okay, so we've gotten off to a good start here. We got some things we're considering. And I told you, you don't have to learn it today. All you got to do is show me that you understand it by the end of the semester, and we do it every day. Not only should you know it, you shouldn't have to study it for a final. All right, and you should be able to retain it and actually use it at the next level, which is what this is all about. Constant repetition so that you don't forget it. Ciao.